So on my EX500 Kawasaki turbo project bike, you remember a while back I went and modified the turbo, the hot side. So I went and ground all this out in here because basically it had a lot of meat on the outside of that. I'll place the other video, or a piece of the other video, in right here so you can see what I did before. So the exhaust nail on the bike now, it's been ground out to this point here to match the exhaust, and I've taped that off to down inside. You can see inside the thing here. Ground a lot of the stuff out inside it to sort of reduce back pressure. It's still making, it'll make 19 pound of boost, so but what I found also was that the wastegate, with the wastegate wide open, it would still overboost, and so I've drilled this out, this little hole, the little wastegate hole here was only a 1/2 inch, so I've drilled that up to 5/8 of an inch. That helped get wastegate control of it, but I'm looking at it more. And what I'm seeing here is that, so you see you have this exhaust wheel sitting in the thing here, runs with clearance obviously, and it has a little cover plate goes down there, so that it matches to the back of the wheel here, a little bit of clearance. So really your effective exhaust area, pointer here, exhaust area flows down through here, through the outer periphery of these tips. Well, look at all this, look at all the exhaust housing stuff here. This isn't very good flow. So what I'm going to do is everything outside of this little mark here, I'm going to grind away and taper it off nicely so that the flow exits onto the tip of the wheel nicely, instead of rolling off this edge and then creating a big turbulence through here and then going on and out. Also then that will increase the area down inside, down here. So I'll have a bit of a grind on that, import the thing, and I'll let you know. And this will basically, what you're trying to do is get the boost and the back pressure to be very similar pressures. Typically you'll have them almost 1-to-1, I think, in a pretty high performance system. So this is on my second turbo. I killed the first turbo I had because I ran it with too small of an oil flow orifice into it. You need about a 55 thousandths diameter hole feeding the oil into the thing, and not much less than that. So this turbo here, this is the other hot side, and I've now modified that as well, same place here, to get this right close to the edges of the wheel. When I did that on this other turbo, it was a huge gain. I had to add basically 18% more fuel to it. So basically now I've got 42 pound injectors, two 42 pound injectors flowing at 89% open time. So that, do the math on that, it's way over 120 horsepower. So I've basically come to the point that I need less and less back pressure, less and less hot side restriction. Well, the wastegate itself is flowing all it can. I've gone and ported that thing out to about 11/16 diameter, to the point that it just seals off there. So what I've done now, or the next thing I'm working on now, is a trick we used to do with the old Cosworth Indy cars. When we would run 3 different hot snails. We'd run a 1.55 for the big ovals, a 1.48 for the smaller ovals and the fast road courses, and then a 1.39 for somewhere, say like Long Beach. Well, with the 1.39 we would have too much back pressure in the thing. It would make the motor a stump puller that we really didn't want. So the next trick to do is to add this to it. So I've just machined this. This is a 40 thousandths thick, 1mm thick spacer ring that goes on here, and then that spaces this heat shield away. So basically what you're doing is you're moving the whole, because of this spacer here, and then now this slips in here, you've spaced, you've given this thing a 40 thousandths bigger gap between this face here and this face here. You're losing, you're basically giving the hot side higher flow. It will lose the power to boost even higher, but I'm at 19.2 pound of boost right now. I don't need more boost, I actually need less. I just need a lot less back pressure, and since I don't have any other hot sides for this, I've got to modify this one. So this is my next trick here. Add this little spacer ring to it, and move this thing away. So that should reduce backflow a lot. The back pressure basically is as high, if not higher, than the boost, so you've got that much exhaust pressure coming back in, and on overlap it's basically polluting the intake charge, and so you're losing power. And that showed there was less oxygen there. And once I opened this thing up, I had to add 18% more fuel to it, so it showed that there was 18% more air flowing into the thing. So I'll try this one now. I think this will be a pretty good gain, and I'll go back and report back on how it is. The other thing I've done to this bike is I've added a even smaller rear sprocket to it. The rear reduction ratio is very close to 1 to 2 now. It's that tall, so this thing just has that much power. It's not funny. And in a 410 pound bike, it's a lot. So it just needed more gearing. It could pull a whole lot more gearing than the basically stump puller gearing it had. Anyway, I'll install this thing and I'll report back. Thanks.